Hey, what's up, everybody? So, the other day we were in class and we were taking a look at this warm-up activity. And the activity in class was a little bit different, but the idea basically came down to this. I had the students put these 6 expressions in a calculator and in the Inspire and calculate them out. And, what we found is when they were sort of mixing and matching them up is that these first two that we lined up were the same. They turned out to be the same value. And the second two, likewise, same thing. We put these two logs in, and we ended up getting, even though they look drastically different, we ended up, or not drastically different, but at least a little bit different, we ended up getting the same value. And of course, yeah, you guessed it, same thing for the last two. We ended up getting the same value for these two logs. So it's sort of hinting at this relationship between these top two and the middle two and then the bottom two. But the question is, how do we get from log 9 of 7 over 5 equal to that right side? And then same thing in the middle and on the bottom. How is it that those two things are the same? And what we did is we kind of went back, old school, and looked at some of these from like about a chapter and a half ago, I guess. I can't really remember where it was, but how would you simplify these? Well, on this top one here, x to the 8th over x to the 3rd power, we remember that this is simplified as x to the 8 minus 3. Okay, and I'll just go that far because that's really, I know that you guys know the next step. I hope that you all know that 8 minus 3 is 5. But I just want to get that step out of the way. And then the middle one here, we're going to look at this as, remember when I raise a power to a power, like 4, x to the 4th raised to the 5th power, that's x to the 4 times 5. And then finally the last one, if I multiply like bases, then I get x to the 2 plus 3 because the shortcut is I add those exponents. And this kind of tells us a lot about why those identities sort of, or those properties came up on the warm-up on the previous page. And whenever I was in high school, and I know that that's like back, like the horse and buggy days with no electricity and all that stuff, when we were carving math problems into the side of mountains. But it really has a lot to do with basically these 3 basic identities. Okay? So the way that I used to like to remember them is if I am dividing 2 numbers, then I subtract exponents, right? And then the others would look something like on this middle one. If I am raising a power to a power, then I multiply the exponents. And if I'm multiplying like bases, then I'm adding exponents. Okay? So if we can remember those 3 generalizations of what we learned a while back, if I can remember those 3 generalizations, that's going to help me figure out a lot about these 3. For example, look at this one here up top. So remember the rule that we just went over, which is like this first one here. This first one here was if I am dividing 2 bases, then I subtract the exponents. Well, let's check it out over here. It's the same thing. If let's see if I can get this to look a little bit better. On the top left here, if you notice what's happening is this is saying let's look at it as in I'm dividing 2 numbers, so I am subtracting exponents, kind of like the situation that I have here on the right side. And then in the middle, and just another note about that, remember that each log, like this log here and this log here, each logarithm is an exponent. So when I say I'm subtracting 2 exponents, here on this right side, on that log base 9 of 7 minus log base 9 of 5, I really am subtracting exponents. The middle one, how that clues me in is this piece right here. If I'm taking a number and raising it to the power, then what's happening is I will multiply the exponents, okay? Just like over here on the right side, how we said we'd multiply exponents, same thing on the left with the logs, except look at the 5 as being an exponent, right? And that 5 is the exponent that we had right here. And then log base 9 of 7 is an exponent. So I'm multiplying exponents. And for all you pure mathematicians out there, they're going to get all worried about what I'm saying here. Let's just kind of go for the understanding and realize this. I'm not going to go through all the proofs, but I just want to go for a basic quick reference on why this is going to work and how we can remember it when we're doing some of this stuff on paper. Finally, the last one. Remember on the right side I said if I multiply two numbers I add exponents, and same thing on the left. On the left-hand side we're going to say, okay, if I'm multiplying two numbers, 7 times 5, then I will add the exponents and look at each logarithm as an exponent. So hopefully that helps you kind of get a good frame of reference for this with these 3 warm-ups, and that'll help us to get into learning target 10, which is I can expand and condense logarithmic expressions. And just in case you need it, there's some supplemental practice problems you can do, and then come ask me for help anytime.